Welcome students. Today we will solve second problem on projectile motion. So let us start today's lecture. So we are given one statement over here. Let us read that statement first. A projectile is fired with an initial velocity of 800 feet per second at a target B located 2000 feet above the gun at A and at a horizontal distance of 12,000 feet. Neglecting air resistance, determine the value of the firing angle alpha. So we are given one situation over here. A is the point where we have placed the gun, and B is the point which is the target of the gun, and a projectile is fired from the gun to that target with an initial velocity of 800 feet per second, and the angle of this initial velocity with the horizontal is given to us as alpha, and we have to find the value of this alpha. So the very first step is that we should first resolve this initial velocity into its components. So this initial velocity is acting at point A. So from point A we will draw two components of this initial velocity, one along x direction and one along y direction. So let us show these two components. So we have shown one component of initial velocity along x direction, and we have labeled that component as 800 cos alpha because angle of this initial velocity is considered as alpha with this component, so this will be cos component. So the value will be 800 cos alpha, and we are denoting it as Vx naught. That is the component of initial velocity V naught in x direction. Now the other component of this velocity will act along y direction, so let us label that also, and it is denoted as Vy naught, and its value will be 800 sin alpha. So the first step is that we should label the components of initial velocity. So we have found that Vx naught is equal to 800 cos alpha and Vy naught is equal to 800 sin alpha. Now we know whenever we solve any problem on projectile motion, we consider two motions of the projectile. One is along horizontal, that is a uniform motion, and other is along vertical direction, that is a uniformly accelerated motion. So we'll consider these two motions one by one to solve for the unknowns. So let us first consider the motion of the projectile in horizontal direction, that is horizontal motion of projectile, and we know it is a uniform motion because it is moving without the effect of acceleration due to gravity, that is g. And we know if we have a uniform motion, then only one equation is applicable to that motion, that is x is equal to x naught plus vxt, where x is the distance moved by the projectile along horizontal, x naught is the initial distance along horizontal, Vx is the initial velocity of the projectile along the horizontal, and t represents the time taken by the projectile to cover that distance. Now let us see what values we know for this equation. Now x over here is given to us as 12,000 feet, which is the horizontal distance between point A from where we have fired the projectile and point B, which is the target of the projectile. So x naught over here is 0 because we are considering motion between point A and B only. And Vx naught we have already calculated as 800 cos alpha, which is the velocity of the projectile along x direction. And t is the time taken by the projectile, which is unknown to us. So let us put the values now. So we'll get 12,000 equal to 0 plus 800 cos alpha t. Now from here we will get value of t in terms of alpha, that will be equal to 15 divided by cos alpha. So in this case we have two unknowns, t and alpha, so let us call this equation as equation number 1 for time being. Now we will consider the vertical motion of the projectile, and we know vertical motion of projectile is a uniformly accelerated motion, and for this motion we know three equations are applicable. The first one is v is equal to u plus at, second is s is equal to ut plus half at square, then next we have v square minus u square is equal to 2as. So let us see which equation we can use over here in order to find the unknowns. If you will consider the first equation, in this equation V represents the final velocity of the projectile in y direction, because right now we are considering the motion of projectile in vertical direction. So that value is unknown to us and t is also unknown. So in this equation we will get two unknowns that will not help us to solve for the unknowns. So we will not use the first equation. Similarly, in the last equation, we have final velocity of the projectile in y direction that is not known to us. So we cannot use this equation as well. So it is better that we should use the second equation. So let us observe this second equation now. S over here is the distance moved by the projectile in y direction, and that distance is between point B and A in vertical direction, and that is 2000 feet. And u over here represents the initial velocity of the projectile in y direction, that is vy naught, and we know the value as 800 sine alpha. T is the time taken, that is not known to us. Then A represents the acceleration due to gravity, that is g, and t is the time taken by the projectile. So let us use this equation and let us put these values. So we have replaced s with y, which is given to us as 2000 feet in this case. Then Vy naught represents initial velocity of the projectile in y direction, and g is taken as negative because g is acting in downward direction, but motion of the projectile is in upward direction, in y direction. Now let us put these values. So y we have entered as 2000 feet. Next we have entered the value of y naught as 800 sine alpha, and the value of t over here is 15 cos alpha from equation 1, and we are solving in feet system, so that means we have to consider the value of g as 32.2 feet per second square. So this value we should remember because we are working in feet system, so this value we have to use for acceleration due to gravity. So we have divided this value g by 2 over here into 15 divided by cos alpha square, which is actually the time. Now you can see in this equation we have only one unknown now, that is alpha. So it means we can calculate that unknown. So let us solve this equation further. So over here we will replace 1 by cos alpha square by secant square alpha, and we will call secant square alpha as 1 plus tan square alpha. And over here sin alpha divided by cos alpha will become tan alpha. It means complete equation will be reduced in terms of tan alpha. So we'll get 2000 is equal to 800 into 15 tan alpha minus 16.1 into 15 square into 1 plus tan square alpha, because 1 upon cos square alpha is equal to secant square alpha, and that is equal to 1 plus tan square alpha. Now this equation will further reduce to 3622 tan square alpha minus 12,000 tan alpha plus 5622 equal to 0. So this is a quadratic equation in terms of tan alpha, and in this equation A is 3622, B is minus 12,000, and C is 5622. So we will use the formula of quadratic equation, that is minus b plus minus b square minus 4ac under root divided by 2a. So from here we will get tan alpha as 0.565. And from here we can get the value of alpha as 29.5 degrees or 70 degrees. So we have got our answer for the firing angle alpha, that is 29.5 degrees, or it can be 70 degrees. So I hope this answer is clear to you. Thank you very much.